Hello, good morning, good afternoon, and good evening. Wherever you happen to be joining me from, this is Jim McKeith, Chief Developer Advocate and Engineer for Embarcadero Technologies, and welcome to more Raspberry Pi, Android, and single board computers with Delphi and C++ Builder. This is our in-depth with developing for and deploying to single board computers, specifically the Raspberry Pi, although that's what I'll be showing mostly, but I will talk about some of the other single board computers and what you can do with them. This is a continuation of the original one, which you can find at embt.co/Delphi SBC with the capitalization you see there on the screen. I am the Chief Developer Advocate and Engineer from Embarcadero Technologies, a longtime software developer, developed a number of different languages, a number of different platforms. My claim to fame, though, is I invented and patented the pattern and swiped unlock that you see on mobile phones, smartphones today. Don't get any money from it, but I get to put it on my slides, which is a good thing. Also, recently, I contributed a chapter to the Internet of Things and Data Analytics Handbook, which the chapter I did was on the brain-computer interface and Internet of Things, looking at the ways that we are the boundary between the brain and the computer is being permeated, and that we're able to interface our brains directly to computers, both for input and output, and what that can mean for the future. Our agenda: we're going to talk about CPU architectures and the RAD compiler, as well as Linux versus Windows versus Android. There was still confusion after my last presentation, so I thought I would revisit that and hopefully answer any questions around that. Then we're going to talk about working with Raspberry Pi, specifically launching your app at boot, connecting to Wi-Fi programmatically, and running a Raspberry Pi web broker server. There's a number of people talking about wanting to be able to do that, run a web server on Raspberry Pi. So we're going to show you how to do that with Delphi or C++ Builder. And then we'll also look at how to access the general purpose I/O pins on the Raspberry Pi as well. So we have four compilers, or I guess five groups of compilers, we'll say. We have the Mac OS and iOS compilers. The Mac OS is Intel 32-bit, 64-bit is on the roadmap. iOS is ARM 32-bit and 64-bit, and we actually technically have a 32-bit compiler for iOS as well for Intel 32-bit, and that's for the simulator, and that's only on Delphi. But you're deploying only with the 32-bit or 64-bit ARM compilers, and Apple's announced that they're phasing out 32-bit support. So pretty soon it'll be only 64-bit on iOS, 64-bit ARM. On Windows, we have Intel 32-bit and 64-bit, and then Android is ARM 32-bit, and I think I saw something about 64-bit ARM on the roadmap for Android, but I'm not positive. Either way, if it is a 64-bit CPU, you can still run a 32-bit app on it. On Linux, we have Intel 64-bit with C++ builders coming soon. Currently, it's only Delphi. There is a research project on the roadmap for ARM Linux, but it is currently not, doesn't have a schedule on the roadmap yet. Now, these first two for Apple, Mac OS, and iOS, the OS and hardware are sold together. So we're not going to really be focusing on those today. We're going to be talking about the other ones, the Windows, Android, and Linux, both ARM and Intel across those. And the reason is because you can't really do a hobby board with Apple. They only let you buy the OS on the hardware, on the Apple hardware, so that limits your flexibility for those platforms. Now, if you're working with an ARM CPU, then you're going to be using Android on ARM. That's the compilers we support. We'll be showing today the Raspberry Pi 3 Model B. I've heard people using the Banana Pi and I think the Odroid, and I can't remember if they're using the Pine 64 or not. I've used the Raspberry Pi, the BeagleBone Black as well. So there's a number of choices you choose from there. Each one's a little different, pros and cons of each. I talked about those in more detail last time, if you want to go back and watch that presentation. And then on the Intel CPU, if you have an Intel CPU, then that means you'll be running Linux or Windows. And the one I've used the most is the Latte Panda, which is a great board. It has the Intel Atom processor, and then running on there, and also attached on the same board is a Arduino. So what that means is you can write your program on Windows or Linux and then talk to the Arduino and have the Arduino then talk to the pins to do things. So you can have a separate program running on the Arduino that interfaces between the pins, the input output, the external devices, and your application. So that's a really powerful solution. I really like that one. I've also been playing with the Intel Compute Stick. I've got a Windows version. They sell both Windows and Linux versions, and they have these at all sorts of price points. So go take a look at these if you're looking for a cheap little computer, but it's just a little stick. It's I can say about an inch across and 3 inches long, and it's got a HDMI connector on the end, and you just plug it into an HDMI port, connect the power, and it boots up to Windows. It has Bluetooth built in, also has USB ports, so you can connect USB ports, and it has an SD card for removable storage if you want to expand the storage that's in it. Nice little computer, designed to be portable or to be your media center computer. But it could also be used, for example, to drive a kiosk or something like that as well. There's a number of other boards you can take a look at, though, too. I'm trying to remember which ones I've heard people using. I would suspect if they list them as running Linux or Windows, which all of those do, it should just work. That's really the reality to it. But those two I thought were kind of interesting choices, and that's why I picked those. Now, a note about Android. Android is essentially just Linux with Java, the Android GUI, and some Google stuff on top. Now, you can't have Android without the Google stuff, the official Google branded things, although Google is one of the top contributors to Android and one of the driving forces behind Android. But for example, the Amazon has forked Android and doesn't have any of the Google services on it. So it's not officially a Google Android. That being said, you can buy an Android device and install Google Play Store and Google services on it really easily, and then have all the Google stuff on Android as well, because Android is a platform, and if it works on Android, it works on Android is really all there is to it. So it's important to understand that, because really if there's something that you're looking at that's Linux specific, if it works on Linux ARM, it will work on, oftentimes it will work on Android as well. Just you need to understand how to get to it and how to do that. So that brings us to the Raspberry Pi 3, a $35 device. You can get it on Amazon and all over the place. Probably familiar with the specs for this, but there they are, and you can find more information about it online. That's what I'll be using today. So there's really two main options for installing Android on Raspberry Pi 3. What I've used in the past was real-time Android, and that's the one that's recommended if you go to the Raspberry Pi community sites. They talk about using RT Android, real-time Android on it, and it's a really nice solution. Unfortunately, they just changed the licensing model on there, so they say it's for non-commercial use only, but they haven't announced what the commercial licensing will be. I asked them, and they said they're planning to, but they're not sure what that will be. So it's a really nice solution, probably the most polished one I've seen. But if you're concerned about, if you're just wanting to do something to mess around with, great solution. If you're concerned about the licensing solution, then I recommend you take a look at Geek Till It Hurts, and they have a release of Nougat that runs on Raspberry Pi 3. It runs on 2 as well. I haven't tried it on 2. 2 is not near as powerful, so 3 should be the great way to go. Although they're running Android on Raspberry Pi 1, so it probably is going to work on a 2, depending on what you wanted to do with it. There's the URL for it. Now, you can also build it from code, and there's the URLs to the GitHub repository and also the Google group where people are discussing it. Now, Geek Till It Hurts builds it from that repository. And if you look in the forum, you'll see where they're posting, hey, I've just made this build, and people are commenting on it, and they tweak it and make improvements. So if you're wanting to build it from scratch, which you can do, and are willing to put some time and effort into it, there's access to the code, and you can build exactly the Android you want. And that's one of the things that's great about Android is it's highly customizable. But if you want something that's built and it's free, Geek Till It Hurts. If you're willing to try and wait out the commercial licensing requirements or don't care because it's a non-commercial, just mess around thing, then real-time Android is your solution. Lots of solutions to choose from. Definitely something there for everybody, and I think you should be good to go with that. So now let's talk about how you're going to connect to the Raspberry Pi Android via ADB. On Raspberry Pi, you're running Android, you need to make sure developer mode is enabled, and I think that both of those solutions I showed are running developer mode. They're rooted and they have developer mode turned on by default. I think. I can't remember. I should have probably reinstalled yet another time, but I didn't. Either way, you know how to do that. It's pretty straightforward. And then you go to settings, about, status, and from there you can find the IP address, which in my case was 10.0.1.22. Now make sure your development machine is on the same network as your Raspberry Pi. And your Raspberry Pi is connected to the network, clearly, otherwise you're not going to have an IP address. I had both those problems today. My Raspberry Pi wasn't connected, and my Raspberry Pi was on a different network than my laptop somehow, so I wasn't able to connect. So those are the two most common issues you're going to have. And once you do that, you can do ADB connect and then the IP address. And then when you do ADB devices, you'll see the Raspberry Pi listed there. Generally speaking, if you're ever having troubleshooting your Android development connections from the IDE, if you do ADB devices and see nothing, then it's you probably have a driver installed wrong or something like that. So that's a really good troubleshooting feature. If it shows up there, it'll show up in the IDE. If it doesn't show up in there, it's not something wrong with the IDE. It's something wrong with the way you've set up your development device. I've had situations where I've disconnected and reconnected multiple times or something like that, and I run ADB connect and it won't connect. Or I do ADB devices and it shows as offline. If that happens, I just reboot the device, the Raspberry Pi, and it works again. Something gets gummed up in ADB. You can also do ADB kill-server sometimes, and that will terminate the server that's running in memory. And then if you do ADB connect again, it will reconnect and relaunch the server, and sometimes that'll clear up some of the problems you might be having. Once you've done that in the IDE, if you switch to Android, it usually just finds the Raspberry Pi 3. If you're already on Android, then just hit the refresh button, and you'll see the Raspberry Pi 3 show up for you. So let's talk about auto-starting your Android app. If you're building a dedicated Raspberry Pi solution, this is probably what you're going to do. You're probably going to have one app that you just auto-start and it just runs. You set it to full screen and it comes up and does its thing. You can have that app respond to different events like the launch event using what's called broadcast receivers. Broadcast receivers is a way you can register with the OS and say, hey, when something happens, notify me. And then when it receives a notification, you can either launch your main app or you can actually launch an Android service in your app as well. Android services are supported by Delphi, and that service can then do something. So the event we're going to look at is the on launch, on boot event, boot complete, I think is what it's called. And it will just start up your app as soon as the Android finishes booting. Works like clockwork every time. I guess if you had multiple apps, you may have some problem, although they should all receive it. They're just a matter of who starts when. But for what you're going to be building, where it's a single solution, shouldn't be any issue for you. You can also have an event. I found sometimes my Raspberry Pi gets disconnected from the Wi-Fi, and so I thought about adding a broadcast receiver for Wi-Fi state change or something like that. I can't remember what it's called exactly, which you totally could do, and have it respond to that and reconnect to the Wi-Fi, which I'll show you how to do. Programmatically connect to the Wi-Fi. Danny Wynn does have a tutorial that he built back with XE5. There's going to be a few subtle changes as far as like some of the units because we simplified a few things, but the code I'll show you works, and Danny Wynn's going to go into a lot more detail about it. He has a lot of great Android tutorials out there. Highly recommended. So web broker server on Raspberry Pi Android. This is something I had a lot of people saying last time that they wanted to be able to run a web server on their Raspberry Pi. So we'll do it with web broker. There isn't a web broker project for Android in Delphi or C++ Builder, but you can take a web broker project and move it to Android. So I'm going to walk you through the steps for that, so you'll see exactly how to do that. It requires a little manipulation, but it works when you're done. You can also build it into an Android service. I'm going to be building it into a Android GUI application, but it could be a service, and that service could be auto-launched on boot. So real complete solution there for that. The reason it works is because WebBroker and Indy also support Linux, and Indy supports Android. So while WebBroker doesn't have an Android project, because it supports Linux, it will work on Android. You could use Indy to build other internet service projects as well. There's FTP servers, mail servers. I mean, all sorts of great stuff in there. So if you're wanting to build some sort of server infrastructure on a Raspberry Pi, this is a great way to go. General purpose I/O pins. These are input-output pins. There's the schematic there, or the diagram of what the different pins do. You see some of the pins have power, some of the pins are ground. The numbered pins are the ones you use for input and output. You see, we're going to be using pin 18, which is what that diagram is showing there. Not all the pins. See, notice all the numbers aren't available. I guess what I'm trying to say. Some of them are specific, like pin 19. I guess it would be. I don't know how the numbering goes. The number's kind of erratic, but some of them are ground, always ground. Some of them are EEPROM. Some of them are always voltage. So you need to know exactly what you're using based on the diagram. You can consult documentation. I found this on fritzing.org. Had some great information on it there. And we're going to light up the LED on that pin there. So you can see actually that's a picture of my Raspberry Pi, and the LED is illuminated, and it's connected as you see there. The way you do this, I found you can do it through the Linux terminal, the Linux shell. And you can access that by, once you've connected with ADB, you just say ADB shell, and it brings you up a Linux root bash prompt. And you can just start running Linux commands from there. Not everything's installed because Linux is flexible, but most of it is there. And so the way you do this is there is a path called sys class GPIO, and in there is how you turn on these pins. And so to turn on a pin, you send the pin number you want to sys class GPIO export, and that turns that pin on. And then you can set the direction of it by saying either echo out or echo in to the specific pin direction, like you see there, and that sets it to output. Then you can write for an LED, you write either a 1 to turn it on or a 0 to turn it off to that specific pin's value. You can do this either ADB shell, or you can send it all as a single line like you see down there at the bottom, and you put the double quotes around the echo 1 greater than path statement there, because if you don't, then DOS or Windows, I guess it's Windows anymore, not DOS, dated myself there for a minute, the Windows terminal, Windows command prompt will interpret that greater than symbol as you redirecting things, and it will look for that value path, and that path doesn't exist on Windows, and it'll give you an error message. So if you get an error message, you forgot the double quotes, put double quotes around it, and you can just send that straight to the GPIO pin from Windows. As far as input and output goes, if you wanted to, actually I haven't looked at input from this, but you should be able to input from it by redirecting from there into a text file, right? And then read the text file. So there's a few different ways you could do it. You're typically just going to be reading one value or writing one single value for most situations, right? You're going to be reading like the current temperature or the current light intensity from a pin. And so there's a simple way to do it. So let's do some demonstrations with the Raspberry Pi. This is my auto starter app I wrote that also manually connects it to the Wi-Fi, because I found that my Raspberry Pi is not connected to the Wi-Fi automatically. So you want to use this as a basis for anything that you want to have running automatically whenever the Pi reboots. Put it in this app. So this should be like your main app is kind of the idea. So you would, if you're going to have a web server, you would embed your web server in here. If you wanted to have do something else, you would put that all in here. So I'm going to walk you through some of the basics of making this into a auto starter. So the first thing is there's a bit of a Java stub here, and the code, let's see, it's in here. Right here is what you need to have. Actually, I don't think you're going to have to change this at all. You can use exactly the way it is, unless you change. Yeah, I guess if you wanted to have it launch your service instead, you would change the class name, right? So right now it's set to launch the native activity, your main activity that contains everything else. If you renamed your activity or something like that, you need to do that as well. But otherwise, all this is set up as a broadcast receiver. It says I want to receive action on boot complete. And when that occurs, we're going to launch that activity and start the activity. Okay, so you can Google this and find out more information about how to work with broadcast receivers to respond to different intents, and how to launch different things if you want to launch a service instead, for example. So what I have here is, let's see, oops, too far. I have a batch file that I use that builds this. I can't remember where I got this batch file. It's probably modified from a few different sources, but I'll include this available for you as well. And it's going to set up the path correctly. So if your path's different, I'm going to be using an old install of the platform SDKs, but I've updated it, Android 24. And yeah, it's just going to go through and build the jar file for you. So pretty straightforward. I call it bootclasses.jar. And then the output's right here. Output is jar, bootclasses.jar. And so then you add that to your, in two places. In here, you add it to Android libraries right here. Just drag it into the libraries there. And also you need to add it to your manifest. Let's see if I can find it here. There's right there, broadcast receiver. We set the broadcast receiver here. And again, we specify what intent we want to receive. And we have the permission. Where's the permission at? I guess I set the permission in the user's permission. I'll jump in there and look at that. Let's see. Yeah, that's it. That's what you have to do. So the bit of Java code, build that Java code, add it to your libraries, and then add it to your manifest. And then it's able to, that Java code responds to, or registers for that intent, responds to that intent, and launches your main activity. I'm going to look here in the project options. I can't remember if that's user's permission I got sitting here. I didn't see it there, so it must be sitting here, right? User's permission. I don't see it. It must be in here. Why don't I see it? I did turn off phone state because I'm not using any of those on here because the Android doesn't have, or that Raspberry doesn't have it. Right there, receive boot completed. I knew it had to be here someplace. I was looking for boot completed. It's receive boot completed. You have to have that permission set. And that's it. It'll work. So now what our app actually does here is, what this is going to do is it's going to, I have a timer set here, and it goes and checks to see if it's connected to the Wi-Fi. And if it's not, it automatically, it programmatically connects to it. And so I've imported a few libraries here, Wi-Fi info. Actually, Wi-Fi info, I think that's not imported. The formatter I imported, that's for formatting the IP address, because the IP address you get back is in this wonky format. I don't know why it's in that format. So you have to run through this format in order to make it into a 10.0.1.22. But everything else is already actually built in. So here, this is connected. It looks at the connection manager, and let's see, the uses statement. Android helpers, these are the base ones you need for working with Android APIs directly. This helpers has like the JString to string and string to JString, stuff like that. This is the JNI bridge, is the actual bridge. You may not need this one, but you might as well include it because you're using it anyway. If you need to get access to context, you need this one. This is the rest of your Java types, and in this case, I'm working with the network, so you need the jni.net. If you're something you need, if you're like, I need this feature, you find it in the Java documentation, you just go search through all the source code, tell you find the one that's what you need, and you include it in here. But then the rest of these, you're probably going to always include these. You tend to end up needing your context use just because that's the way Android works. And then whatever it is you found. If you can't find it, you can find it. Last time I told you about, you can find a lot of them on the FMX Express GitHub repository, or you can use Java 2OP and import it yourself. Really easy to do. I've done both of those. I don't know how many times. Okay, so the timer is going to fire here, and it's going to look to see if it's not connected. Then we do is we get configured networks from the Wi-Fi manager, and we just go through, and if there's none, then we say, oh, there's no networks, and we abort. Otherwise, we get the networks iterator, and we go through each of those networks, and we try to connect to it. And so we enable that network, we reassociate with it, and then we reconnect it. And that will attempt to reconnect to that network. So if there's only one network, and so this is any network you've previously connected to. Once you previously connect to it, it saves it. And this will go through all the saved networks that are currently available and attempt to connect to them. This works great for me. So let's go ahead and show you this in action on my Raspberry Pi. Oh, actually, before I do, I will show you. So I wrote this here. This gets the IP address and has this connected in it because I needed those things for the web broker example. So I just pulled those over for that, and it uses this unit, and then this unit calls the formatter here, which is just the raw header import. Booting up the Raspberry Pi. It's right down here. It's got the LED hooked up. We're going to show later for the GPIO pins. I don't know if you can see the light booting up here on this. Oh, there it is. There's Raspberry Pi. It's booting. And here it is right here running Android. So, I don't know if you saw it or not, but it wasn't connected to Wi-Fi. But here's the app. The auto starter app just started up. And the 5-second timer kicked off. And it found the Wi-Fi network and attempted to connect to it, and it's got an IP address 10.0.1.22. There you go. So here's how I built my Android web broker server. It may be an easier way that you want to do, but this is what I did. So we're going to come in here. I'm going to make a new multi-device application, and just do blank application, and I'm going to remove the main unit from it. All right, and now we're going to come back here again, new, other, and you're going to hear web broker and make a web server application. And do Windows standalone FireMonkey. And sure, we'll do 8080. Oh, save changes to that, yes. Android web broker. Okay. So this is going to be our Android web broker project. Okay, so that was our Android project we just saved. This one new one is our web broker project. And so what we're going to do is we're going to save the units out in our Android web broker. So we're going to say this is the main form unit. And then we're going to save the main web module unit. But we don't need to save the DPR, the project file. But we do want to come here and view source. And we're going to copy. I'll just go ahead and copy all this for now. All right. Now we're going to reopen our web broker project. Don't need to save this. And in here, I'm going to come in and add it down at the bottom. So make sure I clean up when I'm done. We're going to add this here. We started FMX forms, so we don't need that twice. Okay. And then we're going to add these two lines here before the application initializes. All right. Now, if we build this right now, it's going to work on Windows. Oh, it's already running. I have to add those projects in. That's what I'm doing wrong. Add the existing projects in. So I just add these two here to it. Oh, yeah. I got to remove those. Oops. Here. Because I'm adding those in. So I get ahead of myself. Add those two in. There we go. And now I come back here. And now this looks the same as the other one did. Except it has the system startup copy in there. I think that's the only difference. So now I can run this on Windows. And it actually has a form in it. So I can start it. Allow access. And if we bring up the browser window, localhost, and there's our web server application. Okay. But now the cool thing is this can have a target of Android. I haven't tried any other platforms, but it has Android. Now look at this. Hold on. Whoa. Web request and ID web broker bridge doesn't work. It's missing. Okay, that's fine. We're going to just move those over because we know they work because I just told you they did, right? So I'm going to switch back to Windows, say open file at cursor, and show and Explorer, and grab this file here, Control C, and then come back over here and say show and Explorer. So we're in our folder where that belongs, and Control V, paste that in there. So there's that file there we needed, and we come back over here, and we'll go to this one. And we say open file at cursor, and then we go explore or show and Explorer, and copy that one there. And oops, and go back into here. There it is. Okay, so now we can close these out and switch back to Android again. And they're no longer in red. That's because those units now exist. And those units work on Android. So we can come over here and make sure we don't have any errors here. All right, so now we should be able to project build. Errors. Oh, that's right. I have to get this one as well. I forgot that one's separate. So we'll just go back to Windows. Open file at cursor, and then explore, and copy that guy to Android web broker. Okay, and there's an easier way to do this, but this is the simple, quick way to do it. Easier way, more maintainable way, I guess. Oh, I don't want to run this in Windows again. A proper way, but this is the let's get it all working way. Oh, so, okay, that's the other thing. These don't work on Android, so I just take that out. I don't need the open browser window button. That's nice to have, but I don't need it. I'll leave that there, but I'll take out the shell execute. Because we could actually do that. Web broker. Okay, that one's missing. Windows, open file at cursor, show Explorer, a web broker, web const. I think we need that one too. Just copy all three of those. Save trips, right? Oh, haha, that one's already there. Okay. And now I come back and we switch back to Android. Project build. Okay, so we've built it. Now it's working for, we've built it for Android now. Let's go ahead and change this guy here. Right now it says web server application. We'll say Raspberry Pi web server application, right? Because that's what it is. And we need to be able to connect to our Raspberry Pi, which we see is not here. So let's go ahead and Do I have a terminal? I don't. So command adb connect 10.0.1.22. And we've connected adb devices. There's the device. So let's save this all off. We hit refresh. And there's our Raspberry Pi 3. So we'll run it now. And it will deploy. I'm not going to show you it deploying because that's boring, but I'll show you connecting to it now from here. Oh, I didn't add the code to show the IP address. So you can grab that code from the other one and add it in here. And plus I'll have it in the sample as well to show the IP address. Another code I also added was the ability to create a shortcut, which I got from FMX Express. Since you're deploying it through ADB, it doesn't ever actually create a shortcut. That happens when you install it from the App Store. Is useful to have because you're going to have that, you're going to relaunch the application later. So that's easy, good to have. So let's go ahead and start this. It's started, and so now I should be able to go to my browser here and see localhost isn't working, but I can go 10.0.1.22:8080 and Raspberry Pi web server application right there. So we're running WebBroker on Raspberry Pi now. Didn't include the auto start functionality, but I already showed you how to do that. So you can add auto start to this, and boom, you'd have a web server running all the time on your Raspberry Pi. WebBroker that you wrote yourself in Delphi. Pretty cool. For the general purpose I/O pins, I've tried a few different options. It would appear there's a limitation that you can't actually access those particular pins from Android. You can't access it from the Linux side. So, and I know there's a way around it. I just haven't figured out what it is yet, but I did come up with a solution and a use case for it. So what I've done is I'm actually doing this all from the Windows side. Clean this up here. Let's try a few different options. So I'm doing it from the Windows side. So what you could do is you could actually use app tethering. And so you could have your Windows computer connected to your Raspberry Pi via wireless with ADB Connect, and then use app tethering to have the app send a message to the Windows computer to talk to the app itself. I'm sure if someone else really wants to do this, I'm sure you'll probably figure out the solution. It's something I've just missed, but I'll go ahead and show you what I have right now. So what this is doing is I'm just doing I'm executing the commands specifically to do this and just sending the keys here directly to it. So I'm gonna go ahead and run this now, and I'll show you this in action. So here is my Raspberry Pi, and I'm gonna go ahead and hit setup, and setup, you can see, is going to also turn it on. So let's see if this works. Boop, there it's on. Oh, I should have set that to be hide the window. So lights on, lights off, lights on, off, on. So that's a really simple example, but it shows you how to access the GPIO pins and get going. So I'll include the source for this, but this is all pretty straightforward, you know, WinExecs and stuff like that, just running the ADB commands. You could also create shell scripts, bash scripts, and use ADB push to push those onto the device and run them from there. But for some reason you can't. I tried running them from a Delphi app on Android, and I tried this both with Delphi and with Android, and it wasn't working. So there must be something I'm missing, but probably a permission or something like that. And so you can push the scripts on and run the scripts and do different things like that. And like I said, you can input and output both with this. So lots of possibilities, but this just kind of gives you the basics of getting started. I wanted to list out all the steps for creating a web broker on Android. There's probably a better way to do this. I know you'll figure out a more sustainable way for sure. So you need two projects. The first one, you can create a regular FireMonkey app. You're going to remove the unit from that and save it. You're going to come back to this one later. This is your web broker app itself. Then you can create a web broker server. You can choose Windows, standalone, FireMonkey, and that's the three important pieces. Whatever port you want to do is fine. Save the units from that in the same place, but not the project. Okay, now you're going to reopen the FireMonkey project, add those units back into it again, and also add in the project users clause web.webrec and ID HTTP web broker bridge to the users clause. Then you're going to add those 2 lines to the main block of code. And now you need to copy these missing files over to your project folder. You can also just set them up so that they're available for Android in a common users place. If there's any additional places, as soon as you switch to Android and hit build, it'll give you an error message. Just go find those additional files and copy them over. Then you need to remove the Windows specific units from your main form. The shell exec in the launch browser button has a couple Windows specific units it uses. And then switch the target to Android and you're ready to go. Like I said, if you do switch over, there's another one that's missing that somehow I forgot to list here. Just copy it over like you saw me do in the video and leave a comment and I'll update this. Optionally, you can add the code to get and display the IP address from this all done in the auto starter, make a shortcut and make it auto start. Here's some more resources for you. There's the link to the FMX Express article on install shortcuts on the Android home screen. I think that all works pretty straightforward. I don't think there's any changes. There may be a couple changes, but you have the code in mind as well. The auto start code from Danny Wind, the Object Pascal Android wrappers from FMX Express, and then part 1 and part 2 of this webinar with the code and slides are available at that URL there. And with that, it's time for Q&A.
That was a great session. This is Stephen Ball here, and I'm going to be hosting through the Q&A session. Jim's just trying to see if he can get connected in. He's having some Wi-Fi issues where he is at the moment to get connected in. So let's have a quick look at the questions that we have so far. Yeah, a couple of hellos. Yeah, nice to see you online. Thank you. Question here for Jim around the demo. Was Jim using Android from a complete power off? We'll have to ask him that as soon as he gets online. Yeah, it was putting up pretty quickly, which is good. I know one of the things that we do certainly see with Android is that it's a lot faster having a local device to connect into than it is trying to run up the Android simulator. So yeah, it just sometimes seems a little bit faster trying to boot things across. One of the other key things, especially if you're not needing to use the debugging, then to build in release mode and then push that across, because the size of the file is then a lot smaller as you push it onto the device, and that seems to be one of the big bottlenecks around Android, is just trying to get the file converted and across. Kevin saying, great to see Web Broker on Android. Yeah, obviously it's not been fully and extensively tested through, but you know, it's a proof of concept showing that you can get the stuff there and run some stuff through. And it looks like Jim's just joining us. So, hey Jim, can you hear us?
Hey, I got the Wi-Fi working.
Great.
I can. Can you hear me?
Yes, sound great. So there was a question here for you from Roger, who was asking around your device there whilst you're doing the demo. Did you boot the Pi using Android from a complete power off? Because it seemed to be pretty quick turning on.
Yeah, I booted it from a complete power off. Although I think I might have edited part of that out just so you'd have to sit there and watch it all power out. It was a complete power off.
Okay.
But yeah, I probably did edit out part of that just so I didn't have to watch it boot up.
Yeah, no, I was just saying that Android can be a little bit slow in terms of boot up, and also in terms of just getting files and bits across. And definitely whatever you do, don't use the Android simulator, because that is just so slow. Now a question here from Chris about databases. Can you use databases across on there? Well, actually one thing you can do is you can use, there's a free IB Lite which you can use and run onto an Android device. And
yes.
And the other, you can use SQLite as well, depending on what's on the distro that you have. The other option, depending if you want to secure your data properly on the device, because if you're storing any information there, say for example you're building a healthcare device that was going to be connected up to the Wi-Fi and was recording a patient's blood pressure monitor or something like that, you know, then you'd want to be encrypting the data on that device, and you can do that using Interface to Go. So yeah, just keep an eye out for news around that as well. But Interface to Go is a great way to secure your data correctly on that on devices. So that's, yeah, absolutely, there's different options.
Yeah,
the
so
nice thing
on the device, but then you can also connect remotely using DataSnap or a RAD server or something like that to connect to a remote database.
Now, certainly, one of the things, Chris, if you're looking to maybe cache some data on the device, because obviously fetching data constantly when you need it is kind of time-consuming, and will slow your app down. I know certainly sometimes you want to cache specific data out onto a device. One thing that you can look at, and it's definitely worth having a look at, is the interface change views. Interface change views is kind of an IoT award-winning feature of interface. It's kind of unique to interface in the way it works. And we've actually had customers that have SQL Server that have put a copy of interface next to the SQL Server to be able to update locally specific data, and then use lots of devices remotely to subscribe in to that data to be able to fetch the deltas. So anytime anything changes, you're then able to fetch at a field level what's changed. And that's a really powerful feature of change views that scales in an exceptionally strong way, which then allow you to just fetch the delta. And again, as Jim said, fetching that through DataSnap or through RAD server would be the way to go. But you can also do a direct connection. If you're using the IB Lite driver, you could do a direct connection back to an interface server if it's within the network and you've got that exposed. Also, if you're going across the network, like the internet outside of VPN, then you'd want to use a RESTful service like DataSnap or RAD servers.
So there's a question here about the licensing model on IB to go, Stephen.
Yeah. Yeah, just keep tuned around stuff with that. At the moment, there's basically you can buy an X number of licenses and then you can use those and distribute them. If there's specific alternatives that you'd be interested in, then please feel free to just drop me an email over stephen.ball@embarcadero.com, and I say under a VAR contract, then we can go off the typical boundaries of what the price list confines. So there's always options in different ways around sorting things. But yeah, do contact me and we can have a chat about that, Richard.
Now, isn't there a promo going on right now, and I may be incorrect, I don't know, keep up on all these, where you get a site license on RAD server, which does not include IB to go licenses?
No, it doesn't. No. All right. No. The interface is just the backend EMS part there.
Oh, okay. Okay, I thought it included a client license or a IB go license as well.
Android and Pi, is it possible to display movies with something like T-Media Player?
Yes. I haven't tested that specifically, but it should work. I should have tested that. That's something actually I have plans to do something with that, so I should probably make sure. I can't remember if I tested that or not. No, I don't think I tested that. It should work just fine though, because that is all at the straight up Android level, and so it should all be at that level of functionality. So I would suspect that should work. I'll tell you what I'll do. I will test that. Oh, I'm traveling this week actually, and I don't have my Pi with me, so I will have to test that next week. But I would be I would say a good 90% chance, 90+% chance that should work. If it doesn't work, I would be very surprised.
Yeah, so this is part of the Android operating system. So yeah, if the Android distro is good for it, then you should be good to go.
I showed last time I showed the RT Android. This time I showed the other one, the one that's built from the source, the Geek 12 Hertz. The RT Android's a little more stable, I found, but they don't have the licensing model worked out yet. So I would definitely recommend keeping an eye on that one if you're wanting to use Android to see if their licensing model is. Unless you really want to have a free one, then go with the other one and know that it's free and not going to change in the near future.
Yeah, it's great.
I showed you all the resources for if you want to customize.
Okay.
And the RT Android instructions for installing Google Play Store and stuff like that on it as well, which you probably could use those same instructions to install that onto the other one as well. So lots of options there.
Okay, I think that's pretty much it from the questions. As I say, if you think of anything else, then feel free to drop Jim an email over. We'll have another session running about 4 hours from now.
Yep.
So, yeah, feel free to jump on and watch through that. A few people were just sending a message to Jim to say, thanks, great webinar, really interesting. A lot of people have to go and try and grab hold of their Raspberry Pis and other boards and have a play. And I'd say if you want to kind of catch back up with some of the IoT type content, then I'd definitely say it's worth going and Googling the IoT bootcamp that we did that had a whole load of sessions with creating and connecting to boards and Arduino-based boards and being able to apply those on. You know, Jim showed a great board there. Also spoke about a board that had Arduino connected into it as well. Being able to kind of bridge those gaps between the two things is pretty cool, and there's some really, really interesting stuff you can go and do. And I think my favourite part of it is what you can do with the RAD server and the edge devices with what's called a thing point, and being able to then have these thing points automatically discoverable through a REST API call, and then being able to use REST APIs to then actively target specific devices as they're on and off the network, which is an amazing way to build an IoT connected network of things that you can then just run from a central point, a single point, which is pretty awesome. So that's stuff that was covered in the IoT bootcamp. Definitely worth having a look through those sessions, and also shows how you can connect to that from other programming languages as well. So the great thing about that then is that makes your programming effort at the heart of the network or what's being deployed, and means that it's going to be there for a long time, which is great for supporting it and earning the monies off it that way around. So again, Jim, great webinar. Thank you very much.
Sure, absolutely. And the question here about the source being available by Richard, yeah, I meant to have it posted before today, but I will should be able to get posted today sometime. So just at that Delphi SBC link you see on the screen there, I will post the source from today. You will still have to import those units, missing units. I say missing, but Linux and Windows units to into your project manually, because they're I'm not going to distribute those. But if you have the full version, not the trial version, then you'll have access to that source and you can pull those files over.
Great. Okay. I think that draws us to a close. Thank you, Jim. Thank you, everybody, for attending, and happy coding. And we'll see you online again soon.
All right. Bye, everybody. I don't have the source code posted on there yet. I will get it on shortly. I'm actually on the road this week traveling, and I wasn't get all the source code posted before heading out of the office. So in my office, yeah. Is it possible to run a Delphi app on Android things? So Android things, I actually looked into this, doesn't have the GUI layer on it by default, and so there is no so FireMonkey requires the GUI layer, so you would not be able to do that. Now there may be a way to work around that perhaps and get something that works, but I don't think there's a way to get to create an Android things app for yet currently. So the request for the link page, let me see if I can grab that and put it in there for you.
Hey Jim, just whilst you're kind of looking that up, if you're kind of looking at running things, one of the really kind of cool parts of the tech that's in RAD server is thing points and the ability to create using Delphi or C++ builder, basically remote kind of modules that can connect to the local devices, and then have those automatically discoverable through your central RAD server API. So using a REST API, you can query to find out what things are on the network, what services those things provide, and it's possible to service that all out through YAML documentation, which can then be used to kind of basically have a web page that will kind of allow you to be able to test all the REST APIs and also integrate it into different languages. And there's a whole load of stuff that was done on the IoT bootcamp a few months back, specifically looking at building things using Arduino and then moving on, connecting to those with Delphi and then building thing points which were then connected into a network of things using RAD server. So that's a really powerful architecture and something that you've got some really, really powerful direct access through to with RAD server.
Yeah, that's true. So there's the link for the info page. I didn't go into some other things that you can do on here. Because it is Android, everything you can do on regular Android works on here normally. So this was more focused on things that you wouldn't normally be doing in Android. Like you're probably not going to usually run a web broker server on your phone, but and the GPIO pins and stuff like that. But things like databases, you can use Interbase, IB2Go, IB-Lite, SQLite. You can do all the other things you normally would do on an Android app, all the other normal FireMonkey Android functionality. So those are great to take advantage of.
Yeah, I know one of the questions we had in the earlier session was around the movement of data out to the devices, not just the storage of the data there. And obviously you can use RAD server or you can use DataSnap, or you could use there's so many different options for getting data moved around. But one of the things that we did speak a little bit about was how people are using change views, which is part of Interbase, to be able to update a big network of things with specific cache data. So if you've got specific things that are getting updated centrally, using change views on the central Interbase database to be able to pass that information out. And in fact, there's if you actually have a look on the Interbase website, there's a white paper you can download there about change views, and that actually talks about one customer that had 30,000 stores, and they were using change views with Interbase alongside a central SQL Server database, so updating the local data from the SQL Server into Interbase, and then Interbase was managing the deltas to push those out to all of the 30,000 stores, which was something scaled from a replication point that just wasn't possible with SQL Server. If you are looking at distributing and updating data from a central point out to your things, then that's certainly something that's worth having a look at alongside alongside your other work.
Yeah, absolutely. That's a great technology for something like that. So, very good idea. Well, it looks like that's it for the questions. Thank you so much for joining us. Like I said, I will get the code posted up there shortly, and you can grab that, and we'll see you online later.
Cheers. Happy coding.
Take care, everybody. Bye.